Welcome to class today. We are going to go through lesson 25A, and there is a very important equation that we need to know. And this is how to find the vertex. So remember when we did last time's lesson, we only had one or two terms in the equation. This makes it very easy to find the vertex. If you only have one term in the equation, we only have 3x squared, we know the vertex is going to be 0, 0. Whenever I plug in x, that's 0 is going to get squared and then multiplied by some number, which is still going to be 0. So our vertex is going to be equal to 0, 0. When I add in the last term, if I have this equation, 3x squared plus 2, I know my vertex is just going to shift up. So if I plug in 0 for x, that means the x value is going to be 0, and I'm just left with 2. So my vertex is going to be 0, 2. But if I have three terms in the equation, then the vertex isn't always easily seen. So we have to find the vertex using a formula. So our vertex formula, so I want you to write this at the top of your paper, and it's easier to remember formulas and learn them if you can write them down and you just remember how to do them. So vertex is x equals, so remember this is the x value. So to have a vertex, we need the x and y value. So this is how we get the x value. It is opposite b divided by 2a. So in our vertex equations, we have y equals ax squared plus bx plus c. So you find the b value by looking at the coefficient of the x value. So we find the x value and look at the coefficient, and this coefficient, you might be tempted to say 6, but don't fall for that trap. Always watch those negatives. So this b value is -6. We need the opposite of our b value, which is +6. And then our a value comes from the coefficient in front of the x squared value. So we find our x squared, and our coefficient there is 3. Okay, so let's go ahead and find our vertex, which is, and every time you do this, I really want you to rewrite the vertex equation. This is going to help you remember how this equation works and what it is. So x equals opposite b over 2a. So in this case, we have a -6 divided by 2 times +3. So a negative is a positive, and I like to write it like this. Just so I remember, a negative times a negative will equal a positive. 6 divided by 6, so you can cross out the 2 and 3. 2 times 3 makes 6. 6 divided by 6 is 1. Try not to skip too many steps, but when the steps are very easily seen and we're dealing with little numbers, you're welcome to not show your work and to skip those steps in your head as long as you're coming up with the correct value. Okay, so now we know what x is at the vertex. We have to figure out what y is. We're just going to take our x value and plug it back into our equation to find our y value of the vertex. So y equals 3. We plug in our x value, 1 squared minus 6 times 1 plus 2. 1 squared is 1 times 3 is 3. -6 times 1 is still -6. And then we have plus 2. We have our 3 minus 6 is -3. -3 plus 2 is -1. So our vertex, we can start our X and Y chart here. Our vertex is not 0, 0 here. It's actually 1, comma, -1. Now it's helpful if we can visualize this parabola. We look at our x squared value. Is it positive or negative? So it's positive, so we know that it opens up. So I'm going to write that. Opens up. This will help me remember that when I sketch the graph if everything is making sense or not. Okay, I always like to plug in 0 for x just because it's a very easy value. So if I plug in 0 to x, and I can just do this in my mind because I know this is going to be 0, this is going to be 0, and so all I'm left with is +2. Okay, if you can start imagining how this goes in a parabola, we're opening up, we start at 1, and I have the 0 value. So what value is directly on that other side of the vertex, the same distance away from my vertex that 0 is? 0 is 1 unit away from my vertex. So I want to go the other way and do 1 unit the other way away from my vertex, which is 2, if that made sense. If that doesn't make sense, that's okay. You can pick whichever number you want and try not to pick too big of numbers because we're going to be squaring. But here, I don't think it's that as big of a problem because we're going to be squaring, but then we're going to be subtracting some and adding some. So it's probably going to be okay in this case. So let's pick +2. So y equals 3. I'm going to plug in 2. I'm going to square it. -6. Plug in 2 again. +2. Okay, let's see if this turns into be a really big number or not. 2 squared is 4. 4 times 3 is 12. 6 times 2 is 12. So -2. And then +2. Okay, so this is really nice, right? Because I have 12 minus 12, which is 0, and then adding 2, so that equals 2. And that makes sense because the 0 and the +2 are equidistant from the vertex, so they would have the same y value. Okay, let's do another one. Let's do 3, +3, and see which value we get. Y equals 3 times 3 squared minus 6 times 3 plus 2. Let's see what we get here. We have 3 squared, which is 9. 9 times 3 is 27. 3 times 6 is 18. And then +2. I'm going to make the math a little bit easier in my head. I could just go left to right, but I'm going to take -18 and add 2. That'll give me -16. Now it's easier for my brain to subtract 16 from 27. So 27 minus 16, that gives me a 1 and a 1, so that's 11. So that's not too bad. Now, if you want to save yourself some time, I'm trying to think what is equidistant away from the vertex on the other side. And it would be -1. Y equals 3 times -1 squared minus 6 times -1 plus 2. -1 squared is +1 times 3 is 3. -6 times -1. I have a negative times a negative, which is a positive. 6 times 1 is 6. So I have +6 plus 2. 3 plus 6 is 9. 9 plus 2 is 11. So because I chose something that was equidistant, it's kind of like I'm checking my work. Yes, that makes sense. Okay, let's go ahead and plot this. 1 comma negative 1. So 1 comma negative 1 is here. 0 comma positive 2. 0 and then positive 2 is here. 2 positive 2 is 1, 2, 1, 2. And then I have 3 comma positive 11. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That looks good. And then on the other side as well, negative 1, positive 11, which should be somewhere up here. And I'm going to try my best to make a U shape. So it looks something like that. So good. So I double check. Yes, I have a positive value on the x squared and it's opening up. So I can really tell how this equation is going to be graphed. Okay, notice something. I don't have y equals. I have 4y equals. I always need to solve for x or y just to make it easier on myself to graph. So I'm going to divide every single term by 4. It's really important that you divide every single term. That follows the rules of math. You can't just pick and choose which ones you want to divide. It's either all or nothing. So I'm going to divide every single term by 4, and I'm going to write my new equation. Y equals x squared plus 2x plus 1. So remember, it's a common thing that when we have 4 divided by 4, for students to cancel out and think it goes away. It doesn't go away. It just means I have 4 pieces. I have 4 pieces left out of 4 pieces. That means I have 1 whole that's left. So that's a really common mistake. So make sure you double check that and watch out for those common mistakes in math. Okay, I'm going to write down my equation for the vertex. I need to first figure out what my vertex is because I have 3 terms, so I can't just tell by looking at it. So I have x equals negative b over 2a. So I did say negative b, but try to say opposite b if you can. So my b in this case is 2. So I have opposite 2. And then I have 2 times a. So my a term, remember, it's not 0 because x is still there. I'm just a mathematician. I'm going to be very efficient. If I write 2x, that automatically means one of those 2x's. I mean, one of those x squares. So I have 1 times 2, which is 2. Negative 2 divided by 2 is negative 1. Okay, so my x value for my vertex is going to be negative 1. I'm going to re-look at my first term here. It is positive, so that means I'm going to be opening up. So I'm going to just write myself a little note. Opens up. Okay, now I need to find the y value. So I'm going to write down my equation and plug in my negative 1. Y equals negative 1 squared plus 2 times negative 1 plus 1. 1 squared is 1. 2 times negative 1 is negative 2, and then plus 1. Okay, 1 minus 2 is negative 1. Negative 1 plus 1 is 0. Okay, so now I'm wondering, what if I plug in 0 for x? What do I get for y? So I'm plugging in 0 here, 0 here. I get 1. Now I think, what is equidistant from negative 1? So if it helps, you can plot the vertex right now to figure out what's going to be equidistant. That might help you visualize it just a bit more. Negative 1 comma 0. Okay, so it's right here. That's negative 1 comma 0. And my first point is 0 comma 1. So 0 in the x direction and 1 in the y direction. Okay. So the x value that is equidistant from my vertex is going to be -2. So if I do -2, I don't even have to plug it in. I can just automatically say that it is 1. Okay. And I would really like one more point because we're squaring, we're trying to keep this really low. So I could either pick -3 or I could pick +1. +1 is usually easier for me to deal with and do the math. So I'm going to pick +1. But I'm going to write -3 because I'm going to assign that value to -3 as well. So y equals, I'm going to stick in my +1 value squared plus 2 times +1 plus 1. And what do I get? I get 1 plus 2 plus 1. Well, that's a nice number. That's 4. So I can automatically write down 4 for my -3. You're welcome to do the math as well, but you can also just recognize pattern and write it down. Okay, so we have a nice little U shape here. That's what it looks like. And it's up to your teacher if they really want you to identify the vertex. So if that's the case, you can just go like this and say vertex. For me, if I were grading this math paper, them marking the vertex, and when I see this equation as well, that tells me they know that they're finding the vertex. Okay, so here we are at problem number 3. We need to find the vertex first. So we have x equals -b over 2a. Opposite b over 2a. So my b value is going to be 6. And I have an opposite 6. And my a value is going to be this number in front here. Now, what is the coefficient of x squared? It is -1. So I hope that's very clear to you. -1. So 2 times -1 is -2. Negative divided by negative is a positive. And we have 6 divided by 2 is 3. Now I know that my vertex has an x value of 3, and I now need to find my y value. So y equals negative. Now we have to be very careful when we're plugging in our numbers. We are not plugging in -3, we're plugging in +3. And this negative is not inside the exponent. For that negative to be inside the exponent, it would need parentheses. So the negative is outside the exponent. So I have +3 squared plus 6 times +3 minus 4. So I have 3 squared equals 9 times the negative on the outside is -9. And then I have 6 times 3 is 18. So plus 18 and then minus 4. So -9 plus 18 is +9. +9 minus 4 is 5. And then if your teacher wants you to identify the vertex, you can just write vertex right here equals 3, 5. Okay, so I can go ahead and plot that so that I can see in my mind how this parabola is going to be graphed. 1, 2, 3, 1, 2, 3, 4, 5. Okay, so that looks good. And what is my coefficient of x squared? Is it positive or negative? It's negative. So that means it's going to open down. So I'd like to write myself a little note somewhere. I'm going to say opens down. All right. So now what I like to do is I like to pick a point that's on either side of my vertex. And I'm actually going to choose 2 because I'm squaring and I'm going to be multiplying, and these are going to be smaller numbers for me. So I'm going to go ahead and pick positive 2. So y equals negative positive 2 squared plus 6 times 2 minus 4. 2 squared is 4, negative 4. 6 times 2 is 12, so plus 12 minus 4. So negative 4 plus negative 4 is negative 8. So negative 8 plus 12 is positive 4. And then I know I can get a point for free by going on the other side of the vertex, and that is going to be positive 4. So it's going to be 4 comma 4. Okay, and I can go one more on my vertex so I can get a better idea of how this graph is going to look. I'm going to plug in positive 1. Now you could plug in 5 to get the same answer, but because I'm squaring and multiplying, if I plug in 1, it's going to be a little bit quicker for me to do the math because I'm dealing with smaller numbers. So I'm going to do 1 and 5. Okay, so y equals negative 1 squared, then plus 6 times 1 minus 4. 1 squared is positive 1 times a negative is negative 1. 6 times 1 is 6, and then minus 4. So negative 1 plus 6 is positive 5. 5 minus 4 is positive 1. And I can get that one for free by putting it on the 5 because it is equidistant from my vertex. So the y values are going to be the same. Now, I just want to say, these are the values that I chose to plug in and to graph. But there are all of these other values you could have chosen. So there are a lot of values to choose, and it doesn't matter. It's helpful if you get the vertex plus 4 points, but you can get any points that you want to be able to graph this. Okay, we're going to graph 2 comma 4. 2 comma 4. 1, 2, 3, 4. And I graph the other side. I'm going to graph 1 comma 1 and graph the other side. And I have a very nice U shape here. And it's always nice when I have students that can draw really well because their graphs look a little bit nicer, but just do your best. And then I checked, did it open down? Yes. So I know I did everything right. It's a good double check just to make sure that I dealt with all my negatives appropriately. Okay, great. Let's go ahead and go to the other side. Okay, so I only have 2 terms here. Okay, so let's just plug in 0 and see what I get for y. So 0 here, 0 here. I'm getting 0 for y, so I know my vertex is 0. No special formula needed because I only had those 2 terms. When you only have 2 terms, it is much easier to tell what your vertex is going to be, and no special formula is needed. But just to show you that your vertex formula will give you the right answer, I'm going to go ahead and plug it in. So my A value is -4, my B value is +4, and my C value is 0. Okay, so my vertex formula is my X equals opposite B over 2A. So my B value is +4. Let me see, let my camera focus here. My B value is +4, so I'm going to have -4 up here. And then 2 times -4, 2 times -4 is -8. -8. So negative times divided by negative is a positive. 4 divided by 8 is 1/2. So my vertex is 1/2, comma, something. So let's figure out what that something is. Y equals -4 times 1/2 squared plus 4 times 1/2. 1/2 squared is 1/4. -4 times 1/4 plus 4 times 1/2 is 2. -4 times 1/4 is -1. -1 plus 2 is +1. So my vertex is 1/2, comma 1. Okay, let's get a nice easy point. That's 0. 0 plugged in. 0 here plus 0 is 0 for y. And here I really can't do my equidistant thing because of this 1/2. I would have to be dealing with a lot of fractions, and that's actually not making my life easier. So I'm just going to plug in some nice, easy numbers just to see how we're going to sketch this graph. So I'm going to plug in +1. So y equals -4 times +1 squared plus 4 times +1. So I have 1 squared is 1, -4 times 1 is -4 plus 4 times 1 is 4. So that's going to give me 0. Oh, and that works because 0 and 1 are equidistant from 1/2. Let's graph it so we can see that visually. 1/2, comma 1. So 1/2 in the x direction and then 1 in the y direction is right there. It's in between directly 0 and 1. So that's how we get y equals 0 for both of those values. So 0, 0, and 1, 0. Okay, there we go. Well, since we're at 1/2 there, we can do this equidistant thing. I could plug in 1 and figure out where we are. And I mean, I could plug in -1 and positive 2. So let's go ahead and plug in negative 1. Negative 1 and positive 2. So y equals negative 4 times negative 1 squared plus 4 times negative 1. Negative 1 squared is positive 1. Positive 1 times negative 4 is negative 4. 4 times negative 1 is negative 4. Negative 4 minus 4 is negative 8. So if we're not sure, hey, does that work with 2? We could plug it in. So let's go ahead and do that really quick. Y equals negative 4 times 2 squared plus 4 times 2. Okay, so 2 squared is 4. 4 times negative 4 is negative 16. 4 times 2 is 8. Negative 16 plus 8 is negative 8. Okay, so let's graph these. Negative 1, negative 8. So negative 1, negative 8, and then 2, negative 8. And there we are. So now we're going to try to draw a very nice U shape. And there we are. Looks something like that. Okay, so we didn't do our open up or down, but if you notice, we have a negative value on our first term. So that means it's going to open down, and that is exactly how we graphed it. Okay, let's do this next one. First, we need to find our vertex. So x equals negative b over 2a. So what is b? What's our b term in this case? It's almost a trick question because it is the coefficient that is attached onto the x value. Do you see any term that has an x value? And the answer is no. We have x squared. So we have a, we have c, but we don't have our b. So it's going to be 0. Now I could find out what a is. A is 1/4. So 2 times 1/4. But I actually don't need to put anything there because 0 divided by anything is still 0. Remember, in math, we can have a 0 in the numerator, and that's just 0. But if I have a 0 in the denominator, that means it's undefined. Okay, so my vertex, let's do our XY chart. My vertex is 0, 0. I can write vertex right next to that. So great, my vertex is 0, 0. And I need to divide by 4. So I'm going to pick values that's going to make it easier that after x is squared, I can divide by 4. So the first value I'm going to pick is 2 and negative 2 because 2 squared is 4 and I can divide 4 by 4. So 2, negative 2. So y equals 1/4. Again, make sure you write your fraction like this, not in the computerized way. Positive 2 squared minus 3. Okay, 2 squared is 4. 4. Oh, we didn't do the opens up or down. So it's positive, so it opens up. Make myself just a little note. 2 squared is 4. 4 divided by 4 is 1. 1 minus 3 equals negative 2. Okay, and this is equidistant from the vertex. I can just write down negative 2. You can also do the exercise of plugging in negative 2, but again, negative 2 squared is positive 4. Again, nothing is changing. Okay, so now let's plug in 4. I know I don't want to plug in 3 because that's not going, 3 squared is 9, which is not divisible by 4. It's going to give me a fraction and a messy number. So let's plug in 4 and negative 4. Y equals 1/4 times positive 4 squared minus 3. 4 squared is 16. 16 divided by 4 is 4. 4 minus 3 equals 1. So did I do my negatives right there? Yes. That means negative 4 is also 1. All right, let's see this. I think I must have messed up one of my negatives here. Nope. Let me see. Oh, I did my vertex and then I made the mistake. Oh, did you catch my mistake? I'm saying something's not adding up. This can't be my vertex because if I were to plot 2, negative 2, it would be down here. And I know my parabola is going to open up. So I caught my mistake. So my x value of my vertex is 0, but it's shifting down 3. I hope you caught that. So we have, if I plug in 0 for x, I get negative 3 for y. Okay, that is so much better. 1, 2, 3. Okay, that makes so much more sense. Okay, now I can graph my other points. 2, negative 2, 4, comma 1. Okay, and then I've got this very nice wide U shape. So it looks something like that. Okay, great. All right, let's do the next one. 3x squared plus 30x plus 78. Wow. All right, let's go ahead and find the vertex. X equals negative b over 2a. Our b value is 30, so it's negative 30. And then 2 times a, our a value is 3. So 2 times 3 is 6. 30 divided by 6 is 5. And I have a negative divided by a positive, so I have a negative value. So I have negative 5. So that is my x value for the vertex, and now I need to figure out my y value. Y equals 3 times negative 5 squared plus 30 times negative 5 plus 78. Negative 5 squared is 25. 25 plus 3 is 25 times 3 is 75. Then I have 30 times 5. 3 times 5 is 100, is 15. So add a 0, that's 150. So positive times a negative, that's negative. So negative 150 plus 78. Okay, if you think in quarters, then these big numbers are very easy because 3/4 minus 5/4 would be, let's see, is this 5? No, 6/4. 3/4 minus 6/4 is just 3/4. So we have 75 minus 150 is negative 75. Negative 75 plus 78 is positive 3. So my vertex is going to be -5, comma 3. And I have a positive value up here, so it's going to open up. So let's write myself a note that we're opens up. Okay, let me go ahead and graph this so that I get a good idea of how it's going to look. -5, comma 3. Okay, so I'm going to have a little parabola over here that's opening up. That's what I'm kind of envisioning in my mind. Okay, so I can, if I'm going to do equidistant from my vertex, then I can do -4 or I can do -6. All right, -4 and -6. So y equals 3 times -4 squared plus 30 times -4 plus 78. Okay, so -4 squared is 16. Now, I don't have all my 16 times tables memorized, so I'm just going to take this really slow. So I have positive 16 times 3. I know 16 times 2 is 32, and then I'm going to add another 16, which is 48, right? I'm going to say it's 48. So 16, I'm off to the side, 16, 32, and then yes, 48. Sometimes it helps me if I write it down. So I have 48, and then I have 30 times -4. Positive times a negative is a negative. And then I have 3 times 4 is 12. Add a 0, 120. And then I have plus 78. Okay, so I have a positive 48. I'm just going to remind myself by putting a plus right there. And I have a positive 78. 8 plus 8 is 16. And then 7. So carry the 1, which makes 8. 8 plus 4 is 12. And those are plus. So I have -120 plus 126, which is 6. Positive 6. All right. Positive 6, positive 6. Okay, let's try to do -3 and -7. Y equals 3. Now I could plug in -7, but I know that's going to give me really big numbers. I'm already dealing with really big numbers in this problem. So I'm going to plug in -3. I'm hoping that when I have to square it or anything like that, it'll make it a little bit smaller so that's more manageable for me. -3 squared plus 30 times -3 plus 78. Okay, so -3 squared is 9. 9 times 3 is 27. Okay, so far, so good. Positive times a negative is a negative. 3 times 3 is 9. Add the 0, that's 90. Plus 78. Okay, so if I have -90 and I have plus 80, I don't have plus 80, I have plus 78, but let's do plus 80. That's a difference of 10. But I don't have 80, I have 78, so that's a difference of 2. So that means -90 plus 78 is 12. So I have 12, and that's a -12 because 90 is bigger. So I have -12. So I have plus 27 minus 12, and that is 15. Is that right? 15? Someone check my math. Yes. It's hard to do math on camera. So 15, 15. Okay, let's go ahead and graph these. I have -4, positive 6, -4, 1, 2, 3, 4, 5, 6, and same on the other side of the vertex. And then I have -3, +15. So 8, 9, 10, 11, 12, 13, 14, 15. Remember, we're sketching, so we're just trying our best here. And we're getting this very nice, very skinny little U shape. And again, if you're an art major, yours is going to look so much better than mine, but that's a great sketch of the graph. And it opens up, so yes, that looks great. Allison plans to make a wall hanging. She has 36 feet of decorative edging. What is the largest rectangular hanging she can make with edging all around it? Okay, so let's draw a picture. What kind of shape are we dealing with here? And I see in here the clue is a rectangular shape. So I'm just going to go ahead and draw a rectangle and figure out what we're doing. She has 36 feet of decorative edging. Okay, so that means the perimeter around here is going to be 36 feet. I'm going to go ahead and write that. The perimeter is going to equal 36 feet. What is the largest rectangular hanging she can make with edging all around it? So that would mean if we have X here, Y here, Y here, that would mean my perimeter is X plus Y plus X plus Y, or we can say it's 2X's plus 2Y's. So I can actually factor those 2's out, and I can get 2X plus Y equals 36. And then I can go ahead and divide by 2. So divide by 2 on this side, divide by 2 on this side. And if you're saying, hey, wait a minute, I need to divide by each term, this is now one term because I've factored the 2 out. If you don't really see it there, you could just divide 2 by every single term up here, and it would be the same thing. Okay, so then I have 18 equals X plus Y. Hey, let's go ahead and solve for X. We're going to solve for Y. So then I can subtract X over. So I have 18 minus X equals Y. Okay, great. So I don't have to write Y here. Instead, I could write 18 minus X. And here too, 18 minus X. So we could say we want to know what is the largest rectangular hanging. So we want to know the values of X. If I find the value for X, then I can find what length this will be. And then I can plug in that X value here to find out what length this will be. We want to find the maximum. So, because we want to find the largest. So this is a maximum. If I draw a parabola like this, I will have a max value. If I have the parabola open up, I will have a minimum value. Sometimes, especially when you're trying to save money, it can be helpful to find the minimum value, but sometimes we want to find the maximum value, and that's the case here. So if I take this side and I'm going to multiply it by this side, I'm going to find the area, which will also help me find the maximum value of the parabola. Okay, so I need more room. Essentially, I need more room here. So I'm going to kind of come up here. I'll just kind of tax that off there. Okay, so I'm going to take this value and multiply this value to get the area, and I want the area to be maximized. So area equals base times height of the rectangle, which is x times 18 minus x. So x times 18 minus x. And I can go ahead and factor that, distribute the x. 18x. So x times 18 is 18x. X times negative x is negative x squared. Now, if I just rearrange these values, I'm just going to swap them up here. I have negative x squared minus 18x. So now I have a parabola that is pointing downward. So I'm going to have a maximum value. Okay, and now I can find the vertex. If I found the vertex, that would give me the maximum value. So x equals opposite of b over 2a. So my b value is going to be negative 18. So I need the opposite of negative 18 over 2 times a. A is negative 1. So positive 2 times negative 1 is negative 2. So a lot of negatives going on. I like to do a negative times a negative is a positive. Now I have a positive times a negative, which is a negative. Just give me a minute here. Oh, I wrote this wrong. I hope you caught my mistake here. It's right here. I'm thinking, no, that can't be it. Okay. So when something feels wrong, you know you've made a mistake, and it usually has to do with negatives here. So this is positive 18x. And look, when I wrote it here, I wrote down negative. So make sure you make that positive. So in this step, I should have made that positive. All right, so now we have this value down here. My a is still negative 1. Okay, so that's still. So my opposite of b, so I have negative positive 18. So negative, and then I have 2 times negative 1. So 2 times negative 1 is negative 2. Okay, I'm so glad I caught that right there. Negative divided by negative is a positive. 18 divided by 2 is 9. So that means my vertex is going to be 9 comma something. Now in this case, I want to know what's the largest rectangular hanging. So I actually don't care about the y value in this case. So I only care about this 9. So you can plug the 9 into back to my equation up here. I've got this equation. A equals negative x squared plus 18x. You can plug that back in to find how big the area is going to be. And I guess I do care about that, right? So if my x is 9, that's going to make my area the biggest. So I'm going to go ahead and find out what that is. So if I plug in 9 here, so x equals 9, then what will y equal? So 18 minus 9 is 9. So that also equals 9. So whenever we're maximizing area, it's not surprising that we get a square. A square maximizes the area. That's why if you build a square house as opposed to a rectangular house, you'll save money on the outside materials. You will use less siding to get a bigger square footage. Okay, so my vertex is actually going to be 9, and I plug it back into my equation, area is negative 9 squared plus 18 times 9. So 9 squared is 81 times a negative equals negative 81 plus 18 times 9. And I don't have my 18 times tables memorized. So I'm going to go up here and do a little bit of math. 18 times 9. 9 times 8 is 81. Oh, 9 times 9 is 81. What am I thinking? 9 times 8 is 72. 9 times 9, 9 times 1 is 9, plus 7 is 16. So 162. So I need to do some more math. I need to take 162 and subtract 81. 162 minus 81. 2 minus 1 is 1. 16 minus 8 is 8. So I end up with 81. And that's not surprising because I also could have found these sides. 9 times 9 is 81. So I also could have done it that way. So if I have 36 feet of decorative edging, then the biggest rectangle, which is actually a square that I can make, has 81 square feet and 9 on each side. All right, that is it. I hope this was enjoyable for you and that you understood minimums and maximums. We introduced that topic just a tiny bit with this great word problem, and I will see you for next lesson. Bye.